Dear students, today we are going to discuss about the introduction to algorithms. So why do we need to study algorithms? First of all, what is an algorithm? So we need to answer all these questions before we delve into the topics of algorithms. So an algorithm actually is named after a Persian author by name Abu Ja'far Muhammad ibn Musa al-Khwarizmi. So this word has taken special significance in computer science because algorithms form the backbone of all computational procedures. Whether it is implemented in C or C++ or Python, algorithm is the first step written to solve any problem. So after defining the algorithm, let us analyze what is the need for studying algorithms. So algorithms, as I said, algorithm comes from the name of a Persian author, Abu Ja'far Muhammad ibn Musa al-Khwarizmi, who wrote a textbook on mathematics. So what is an algorithm? So there are so many definitions. Basically, it refers to a method that can be used by a computer for finding the solution to a problem. To be specific, it is defined as a finite set of instructions that, if followed, accomplishes a particular task. So even at home, when you want to cook a new recipe, we need a set of instructions. Or if you are installing a new electronic gadget, that comes with the manual. So the first step is we just read the manual where the steps are clearly stated in order to install the new gadget. Okay. So algorithm is similarly a finite set of instructions to be executed in order to find a solution to a problem. So when before executing before finding a computational procedure, we need to write an algorithm in any language. It could be basic or simple English language. Generally, there are some criteria, there are some important criteria that should be satisfied by an algorithm. So for some 5 important criteria to be satisfied by the algorithms are input, output, definiteness, finiteness and effectiveness. So input. So an algorithm will work based on the input. So 0 or more quantities are externally supplied. Suppose if you want to add 2 numbers, then you should provide the input, the 2 numbers, you should provide the 2 inputs, say A and B. Right? Similarly, output, at least one quantity is should be produced. Otherwise, there is no meaning in writing an algorithm. So an algorithm should produce at least one output. It could be more than one output. Third criteria is definiteness. So every instruction should be clear and unambiguous. So it should not be vague. For example, if you say that 5 divided by 2 or 0. So anyone, either a person or a computer, will be confused whether we should divide 5 by 2 or 3. So each instruction should be stated clearly and unambiguous. The fourth important criteria is finiteness. Finiteness, that is, the algorithm should terminate after a finite number of steps. So if we trace out the instructions of an algorithm, the algorithm should terminate after a finite number of steps. Otherwise, if the algorithm is implemented as a computational procedure in any programming language, then the system will be hanged because it will be caught in a loop. So you need to make sure that your algorithm is finite. Effectiveness. So every instruction must be very basic and also feasible. So for example, arithmetic using integers is very effective. But the same arithmetic if we are with the real numbers, it will be somewhat complex. But you have to see that whatever instruction you implement, that should be very basic and effective. Normally, after defining the criteria for an algorithm, you must understand the difference between an algorithm and a program. So now the first step is we are defining an algorithm. So next, how are we going to implement an algorithm as a computational procedure? Because our aim is to write algorithms for solving problems using computers. Now we say program, right? So we say C program, Python program, C++ program, Java. So what is the difference between an algorithm and a program? So an algorithm is a set of finite steps written to solve a particular problem. Then what is a program? So any algorithm implemented in a particular programming language is known as a program. So if the algorithm is implemented in C programming, then we call it as a C program. If the algorithm is written with C++ syntax, then it is a C++ program. So this is an important and frequently asked question. What is the difference between an algorithm and a program? So an algorithm written in a programming language is called as a program. Hope you understood the definition for an algorithm and then the basic criteria to be satisfied by an algorithm and the difference between an algorithm and a program. Basically all undergraduate computer science curriculum will have a course on algorithms. So what is the need for studying algorithms? What do we benefit? What are the benefits for the students to learn this particular subject, algorithms? So normally our aim is to solve day-to-day problems, real-life problems using computers, right? So suppose if we are given a problem to be solved, you must know what strategy will be ideal for solving this particular problem. So this study of algorithms will help you to choose the appropriate strategy, algorithm strategy for solving the given problem. So we'll be discussing different strategies like divide and conquer, recursive procedure, greedy method, dynamic programming, backtracking, right? So we'll be discussing different algorithm strategies, and once we learn all those strategies, we'll be able to choose the right strategy for solving the given problem. So as I said earlier, algorithms that are definite and effective are called as computational procedure. So a program is the expression of an algorithm in a specific programming language. So that is the difference between an algorithm and a program. So now our major goal is to devise algorithms, right? So in order to devise an algorithm on our own, you must know the existing standard strategies, algorithm design strategies. So once you study this algorithm, it will be easy for you to devise new and useful algorithms. So the common algorithm strategies are divide and conquer, greedy method, dynamic programming, backtracking, etc. So we learn how to devise new algorithms. The second advantage is we learn to validate the algorithms. So normally after writing the algorithm, we should know whether it works correctly for all legal inputs, right? That is validation. Even if we cook a new recipe at home, that should be validated, that should be tasty, or whether we have added the proper ingredients and then we have got the correct taste, what we intended for, right? So that is validation. So The algorithm should be validated whether it computes the correct output for all possible inputs. That does not mean that it should be verified using a programming language. In general, we should validate whether it will produce the correct output for all possible inputs. So once the validation is over, we can write the program. It can be implemented in any programming language. So we consider this validation process can be executed as in two steps. The first we write the program, and then the second one is program proving. We call it as program proving or program verification. So the study of algorithms will help the students to validate the algorithms. So this proof, how do you prove that this algorithm works perfect for all possible inputs? There are different ways. That could be expressed as a set of assertions about the input. These are the inputs and these are the outputs, and then we should match the whether for this particular inputs the outputs are correctly produced. The second form is a specification, which can be expressed in predicate calculus. Hope you know what is predicate calculus. Say for example, man is mortal can be expressed as in a proportional form, that is for every x excuse me, for every x, p of x, where p of x is the predicate which denotes x is mortal, and for every x represents all. This stage, there is a validation stage, should ensure that this particular program will work correctly. Not a program, that algorithm will work correctly. The third important phase which we learn by the study of algorithms is performance analysis. Excuse me. So we learn how to analyze algorithms. Now generally when an algorithm is implemented using a computer program, it uses memory and the CPU time. So these are the two metrics, or you can say these decide the performance of any algorithm. So how much computing time and how much memory are utilized by an algorithm. So we use these two important parameters for analyzing the performance of any algorithm. So this performance analysis refers to the task of determining how much computing time and storage is required. So this particular phase will answer the questions: how well an algorithm performs best in best case, worst case, or an average; whether the algorithm performs the task as we intended. So suppose we are writing an algorithm for generating the Fibonacci series, we need to verify whether the algorithm produces exactly the Fibonacci series. So it is a challenging area that requires great mathematical skills. So a lot of research is going on in this particular area for analyzing the performance of any algorithm. The last one is testing. So the study of algorithms helps us to test our algorithm. Testing consists of two phases: debugging and profiling. Debugging is the first phase, profiling is the second phase. Actually, debugging is the process for identification of errors in the algorithm. Suppose we are executing the algorithm, we need to find out whether there are errors. There may be say syntactic error or semantic errors. You need to identify those errors. So debugging identifies the presence of errors in your program, in your algorithm. On the other hand, profiling, it is otherwise called as performance measurement. So this process involves executing the algorithm with known data sets and then measure exactly the time and memory. So when you are the profiling is actually the performance measurement phase. We run the algorithm with sample data sets and measure exactly how much computing time and memory are used by the algorithm. So this is the last one, testing. So the study of algorithms helps us to devise new algorithms, helps us to validate the algorithms, helps us to analyze the performance of the algorithms, and finally to test the performance of the algorithms. Thank you for now. We will discuss the next topic in the next